it's not like an unpleasant smell. It smells like.
Could be the room.
I don't know. I can't even identify what it smells like.
Do we even have a
It smells
room?
odd.
Does this work? Can
Can I place it?
Huh? Oh, it does.
Maybe it's just like rain.
It smells like a bad air for me.
Friction.
R equals mg.
12
Fraction.
Sandwich. Lovely. R. Is that R equals mg?
Yes.
Yes.
What was the other one? It's F-A-Y.
S max is what it's meant to say. But it's a bit hard to write.
R equals mg.
Okay.
and there's mu r.
You've got mg this way.
How's it R?
For resistance.
The reactant force. Wait, Leon, have you even started recording?
Yes.
Oh, right. I didn't realise. Okay, so friction today. So today we're starting off nice and easy.
Oh shoot, my purpose in that video, isn't it?
Yeah, but it's not enough, so. Unless you don't want me to cut it out.
Uh,
No, I think we should let our viewers just hear my belch.
Alright.
It's not.
I have referenced this in my UCAS.
Eh?
I have for my one of my
oh, for your personal statement.
yeah. I slapped in the
Yeah.
one of my drafts. I slapped in the thing.
Yeah, that'd be self-teach. Anyway, so it's nice, nice friction. No angle.
What's that P? P is.
P is the pulling force.
Ah.
I mean, it's just
Wait,
the force going the other
What's the
direction.
dot equation you wrote there? F max equals what?
Mu r.
Okay, I just want to check.
Yes. So this here is friction. If you hadn't guessed, hence why it's an F.
When you get the question wrong, you got to be kidding me.
No,
Yeah,
shot.
okay. So essentially, the stationary friction is equal to, any guesses? Danny?
Yeah, man. You.
It's either 0 or 1.
US.
Oh no.
US, US, not
Is
US.
that F going backwards
Where?
on the free body diagram?
Yes.
Yes.
Because it's friction. It's opposing the force.
Yeah, okay.
Well, it's less than because it's just FS. And then F max is equal to mu. Mu is the coefficient of friction, I should probably mention that. R is the reactant force, which is equal to the weight. In this case, because we have no angles. So it's nice, lovely things.
And
Nice and lovely.
mu has no units.
Debatable.
Mu has no unit indeed. Mu is just
Mu.
normally given as, it just says, it doesn't have any units.
You got to be kidding me.
Anyway, some things to note that if P is less than or equal to F, then there is no, then essentially F is equal to P and there is no movement. That might be a bit small down there, that says movement. If P is greater than friction, then F is at its max, which is equal to mu r, and motion occurs, essentially. Well, the block will accelerate it. Well,
Or is it if F equals P, that it'll stay at a constant movement? So that technically the movement is no acceleration.
if it's less than or equal to, there is. So essentially, if P is less than or equal to, F max, then there is no movement because P is not strong enough to break the friction.
I'm saying
Therefore, the friction will be equal to P. However, if there is movement and F is equal to P, then it is a constant. Constant thingy. Yeah, it did confuse me a bit, the fact that when F was equal to P, there was like, find the velocity, find the constant velocity, because, yeah, essentially, normally if it's less than, if it's less than the friction, stationary friction, but if it's kinetic friction, then it's slightly different.
Yeah.
Because kinetic friction is kinetic. So, that's essentially the theory for this lesson. So we shall go over some examples now. When you're here, I need to see what the values are.
I'm not going to stop using it.
So we have a block, mass 0.75 kilograms of force, and it's getting pulled with 0.4 meters per second. Yep. Friction always acts opposite to movement. I don't know if we said that before, but I should say that. Friction is always acting in the opposite direction. This here is then 0.75 G and reactant force. Okay, we need a few other values. Mu equals 0.3. Okay, so that's what we've got for this question. First things first, we find R, which is equal to mg, so 0.75 g. F is equal to mu R, 0.3 times 0.75 g, and then I have the number written down here. So this is equal to 2.2 newtons for the frictional force. We are to find the acceleration, I probably should have mentioned that. F equals ma 2.2 0.75 a is equal to 2.2 over 0.75, which gives us minus 2.94.
Minus?
so. Yes, this will be at movement and it's decelerating because friction's
Sorry, this is, decelerating.
Right, okay.
2.94, because it's just kind of floating along.
9.4, right?
Yeah. Find the distance covered. I should have written that down really. Find S covered.
No, you find it lost, so you're finding acceleration.
We did.
Yeah.
Well, it's a question find S and then you're just using acceleration like
Yes.
to some code.
You're finding the S travelled by the block. So the block is set with an initial velocity of 0.4 meters per second. It then travels for a certain amount of time before it comes to a stop. It's to find the distance travelled in that. So you have to find out A.
Does travel have two
What is that?
Yeah, two L's.
What?
Does
Oh.
travel have two L?
No, one.
Yeah, okay. So
V squared equals U squared plus 2AS. 0.4 squared equals 0 squared plus 2 times minus 2.94 times S.
Math injuries, my hand caught
The holder. I should have brought my calculator.
Okay.
Very good.
Where's your fucking
So, so I'm going to state what something different is so. Oh, it is usually times. Wait, I got it. It needs to be times. No, just do that.
Man, wait, just do
Daniel, what acceleration? Should it not be? Ah,
What? 22. No, it should be 2.93. It's 20. It's not 22. It's 2.2.
well, it's 2.2.
Yeah.
Oh.
Oh, sorry. The dot was not visible. Yeah. Sorry. my bad. So then S is equal to. I've got the number written down here. 2.7 centimeters.
2.7. Sick.
Centimeters.
Yeah.
Okay.
It does decelerate kind of quick.
That's really quick. Love it.
Yeah. Friction's the
Truest is near 3 meters per centimeter. I'm just with the lesson here and all of that.
Yeah.
That's the solution. You know, just everyone goes to sleep. We just stop doing that.
Okay, that's that one done.
How many examples are there?
I mean, I've got 3 or so. They're really easy. I'll get you guys to like kind of do it if you know what I mean. So next one.
You're so slippery.
1.
2.
So there is a 10 kilogram block.
1.
Yes. It's on a
Oh, it's so sweaty.
horizontal, which I'm just writing as horrors. Floor. Coefficient of friction here is equal to √3/4. Find the P needed.
What does that say? Rough hour.
Rough horrors.
Horizontal.
Alright.
Horizontal. To just pull the block. That's it.
Is that √3/4?
Yeah. Okay, so
Fine.
we can draw this out.
I don't think I
We've got R, we've got 10G, 10P,
Find P to just pull the block.
find P to just pull the block, yeah. So this is what we're on, right? Pretty much. We state what R is equal to. R equals mg, and G F equals mu R √3/4 times 10G, which is equal to 42.4. So 42.4 will pull it at a constant velocity. So that's the answer. 42.4 newtons.
Sick.
Okay. I'll put up another one. And you guys are doing stuff. What stuff is that?
That's the good stuff. Yeah, just moved it off the table.
So I'll just draw the diagram for this. Let's not draw that high up. We've got the block, again, it's on a horizontal, we've got W, and we have up.
Can you show out what you're trying to find as well?
Where are defined Fs.
Okay.
FS. Is that 3 kilogram there?
Yes.
Cool.
All units are in kilograms.
Cool.
And coefficient of static friction is equal to 0.3. Wait, no, it's not 0.4. Okay, so that's all we need. R equals W, which is equal to 3G. F equals mu R, which is 0.4 times 3G, which is equal to 11.8 newtons. And then the next ones we'll kind of get you guys to work through, or the next one, I guess I should say.
What about this building?
Oh, you know what happens.
Ah!
No. Alexander's just waffling.
Oh, I see. That's
Yeah.
nice. So for this one we have
You that
a block, as usual,
Every day.
5 kilograms. R W, it's got 13 newtons being pulled on it, and we have friction.
See what the
Acting backwards.
Just walk square around his face.
Was that say 30 newtons?
You can't say that.
30 newtons. Getting pulled.
Yes.
Cool.
So, what the question asks is, pretty much, is there motion? If so, find it.
Find what?
Find acceleration.
A.
So, yeah. Okay, so what do we do first?
Find R. Find G.
So, okay, so we found R. After we've done that, what we're going to do?
Diffuse. What?
No, what are we doing after we find R? So we've stated R.
Find the force.
Yeah, we find friction. So U R 5G times 0.6. Which is equal to, so
Yeah,
24.
My eyes are bad and I can't see.
29.4
So this
newtons.
is closer to the board then.
I was looking at it now. My eyes are just bad. Ear replacements.
So there is motion because there's a larger force pulling it.
Yeah.
Yeah.
I should get
Therefore, it's greater than 29.
Five minutes
Four.
I'm gonna catch your eyes. Nothing wrong.
Therefore,
I'm just saying that it's creepy. Think about it.
the block will move. Mm-hmm.
What number does it say?
I use FMA to find acceleration.
Basic.
F equals M.
No, Alexander was asking a question.
Doesn't matter. Never mind.
Doesn't matter. Okay, so it's almost as P take U R is MA because the force is the pulling force take away the frictional force.
Yeah.
So
Oh, yeah,
they're essentially like confused noises from Danny.
No, I mean, yeah, it's a good one.
Okay then. So 0.6 is equal to 5.
F net there. Fixed it.
Hmm?
If you put F net, no.
Net?
Sure.
Yes.
If you put F net instead of that.
Yeah,
then
like
fine.
F net's the unbalanced force.
Yeah.
What would you rather me?
No.
No.
F net would be 0.6 meters.
Alright.
Like instead of writing
Oh.
P minus mu R, you just
Yeah.
write F net. It's good.
I mean, doesn't matter, okay? They both work. And then after you've got that, you put in whatever 0.6 over 5 is.
Or 5G in this math video.
Go.
which is 0.12.
0.12.
Yeah. And then you can do this with other numbers, you know, if they say, what if p was equal to 28? What would happen?
No motion.
Yeah.
Because it's less than friction.
What if it's 36?
There is motion because it's larger than friction and you just not balance force is like 6.6 or whatever.
And it's then 1.32 meters per second.
Alright.
Sometimes for this, like when you have the 28, you'll find the friction that is there, and the friction will quite simply be equal to. So the friction force will equal 28 newtons when P is equal to 28.
Okay.
Quite easy. And that is. Oh, I shouldn't have put this one out first, should I?
Nope. I'm pretty sure that was so right.
Sorry.
Fantastic.
I can rewrite it if you need it.
I'll just force Xander to try and read my handwriting.
That sounds like a threat. I mean, it is a threat. Okay, so that is all for today, theory-wise. Questions? I wrote down. There were lots of them. Okay, so it's in the Understanding Mechanics strip, which I'm shortening into UM, pages 110 to 114, and do questions 1, A to I, because the ones after I are with angles, and 2, A to C, 3 to 11, 14 to 25 are pretty much all the questions that will be able to be done with all this. So that's all. All
3
3
to
to
11, then 14 to 25.
Yes, 3 to 11, 14 to 25. That should be an A.
Oh, nice.